So welcome back again on 100 days DSA mastery. In this one, we'll be doing the insertion sort algorithm in Python. So first, as always, we're going to go into the theoreticals and then we'll move to the practicals. So first, we'll just look at the definition and then we'll move on to the advantages and disadvantages, and after that, some real world applications. After that, we'll do the coding. So let's just look at the definition of it real quick. All right, so insertion sort is a simple and intuitive sorting algorithm that builds the final sorted array one element at a time. So what it basically does is, let me just give you a step-by-step process. First, it starts with the first element. Assume that the first element is sorted, like the first element is the smallest one. Just assume that. Then it picks the next element from the unsorted portion and then it compares. It compares with the sorted portion and then it sees whether which one is bigger. So if the new element is bigger, then it will put it afterwards, and if it is smaller, then it will be placed before the first element. Now, what it basically does is it just takes out, and just do the exact same thing over and over again. It's pretty much similar to what we have studied in the previous one, like the selection sorting algorithm. It's pretty much same, but not exactly, pretty much. Most of the part is. So let's just look at the advantage of it. All right, so the advantages of it is pretty simple: simplicity, adaptability, stability, in-place sorting, online algorithm. So simplicity, it's easy to understand and it has minimal lines of code. Like genuinely, insertion sort can be implemented with minimal lines of code. Then adaptability, it's really efficient when it comes to nearly sorted data, which is pretty similar to the bubble sort algorithm, right? Then stability, it has like the stable sort, unlike the selection sort. So in-place sorting, minimal memory usage. The algorithm sorts the list in place, requiring only a constant amount of additional memory, like the space complexity. Then the last one is online algorithm. Like it is really good with handling the real-time data which comes online, not through the offline stuff, but online, like the real-time data. It's really good with handling that and makes it really suitable for online data processing. So what are the disadvantages of it? So the first one is inefficiency. So inefficiency basically is not applicable on every single dataset, but specifically on large dataset. And the problem is time complexity. It takes a lot of time, which makes it inefficient when it comes to working with large datasets. Then the number of shifts is one of the main problems because it requires a lot of computational power, which makes it expensive. Then what else do we have? Not ideal for random data. Limited applicability. While effective for small or nearly sorted data, insertion sort is not suitable for large and random ordered data sets. When it comes to large or randomly ordered data sets, it's ineffective. It's genuinely really ineffective. It takes a lot of computational power and it's really inefficient. Then what else do we have? Comparison based sorting, not optimal. Not optimal. It is inefficient compared to any other advanced sorting algorithm, genuinely, when it comes to doing the comparison stuff. So let's just see what do we have in real world applications. It is used mostly in the education softwares and embedded systems. That's it. Let's just move on to the coding part. All right. So we're now on to the function of insertion sort. Let's just do that real quick. All right. So what do we do? Now the first thing that we do is transverse from 1 to length of the array. So for that, what we do is create a for loop. That's how we do stuff. Most of the algorithms are exactly the same. Most of the algorithm plays the exact same, let's just say, protocol, a set of rules. Most of algorithms have the same set of rules, same protocols. First you create a for loop, then you compare them, then you swap them, then you return the array. That's it. That's all of it. They just have is a little bit different approach, but at the end of the day they do the exact same thing. Just look at this one. Move the element from the array 0 to one greater than there to the position of ahead the current file. So what are we doing right here right now is moving the element of the array, right? So let's just say that we have an array element 0. Then what we do is move the element that is greater than the key in the position ahead than their current position. So what basically key is our first element right now, and then it will compare it with the last element, and then it will see, okay, done, boom, move it ahead, move it ahead, move it ahead. If it's bigger now, okay, place it up here, then look at the next one, move it ahead, move it ahead, until it is perfectly sorted for every single one of them, and insert the key element at its correct position. That's how it works. So the logic is really damn simple. You can just see, like, it's 1 2 3 4 5 6 7 8 and 9 lines of code. That's it. 9 or maybe 10. Okay, 11 lines of code. That's it. 11. And we have like left a space up there. That's why it's 11 lines of code. Otherwise it's just 10 lines of code. 10, like, damn 10 lines of code. It's too small. All right. Okay, so let's just print it real quick, and once we print it, it is done. Boom, we're done with it. All right, so say 3 and okay, we have our data sorted. That's how it is. That's how simple it is. So see you in the next one with some new algorithm.